Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam, whether you're targeting a grade 7 or pushing for a 9. Let's get into it.
Hook. This one question lost more marks than any other on last year's higher tier trigonometry paper. Given two sides and a non-included angle, find the missing angle. It sounds simple, but almost a third of students gave the wrong angle. You need to hear why.
I promise no jargon for the first 30 seconds. Picture a triangle with two known sides and an angle opposite one of those sides. Sometimes that set of information can give two different possible triangles. Miss that and you lose marks even if your arithmetic is perfect. Let that sink in.
The concept. Right, quick warm-up, SOHCAHTOA and basic labelling, opposite, adjacent, hypotenuse. If any of that feels fuzzy, pause this and practice one right-angle question. For everything else, we're dealing with non-right triangles, so we need the sine rule and the cosine rule.
Sine rule first. It says A over sine A equals B over sine B equals C over sine C. Practically, if you know an angle and its opposite side, you can compare to another side or angle. Use the sine rule to find missing angles or sides when you have either two angles and a side, or two sides and a non-included angle.
Cosine rule is for when you know two sides and the included angle, or all three sides. It's c squared equals a squared plus b squared minus 2ab cos c. Use the cosine rule to find a missing side, or to find an angle by rearranging to cos c equals a squared plus b squared minus c squared over 2ab. Say that out loud as you write it. Examiners like to see the formula written clearly.
Now, the tricky bit, the ambiguous case, often called SSA or the non-included angle case. Imagine you know side A, side B, and angle A, where angle A is not the angle between A and B. When you use the sine rule to find angle B from sine B equals B sine A over A, you can get one value for B, but sine has two possible angles in 0 to 180 degrees, B and 180 minus B. That's why two triangles can fit the same data.
Important reasoning step. Always check whether both possible angles are geometrically valid. If you compute B as, say, 30 degrees, the other possibility is 150 degrees. Add either candidate to the known angle A and see whether the sum is less than 180 degrees. A triangle's internal angles must total 180. If one candidate makes the sum exceed 180, reject it. That's the simple filter that stops careless answers.
Also, if A is acute and A is shorter than B, you might get two possible triangles. If A is longer than B, sometimes only one or none is possible. The short rule, solve for the angle using the sine rule, list both possible angles, then test each against the triangle sum, and where needed, use the cosine rule to check side lengths for consistency.
The exam technique. Here's where the marks are. For a typical 3-mark trigonometry question, the examiner looks for 1 mark for setting up the correct formula, M1, 1 for correct manipulation or substitution, M1, and 1 for the final correct answer with units or degrees to the required accuracy, A1. If you show the sine or cosine rule written explicitly, that's your first M1.
Exactly what to write. Line 1. Write the named rule. For example, sine rule. A over sin A equals B over sin B. Line 2. Substitute numbers. B over sin B equals A over sin A, so sin B equals B sin A over A. Line 3. Calculate. B equals sine inverse of value equals, and then write or B equals 180 degrees minus, ambiguous case. Then test both with A plus B less than 180. That small demonstration often wins method marks even if the final arithmetic slips.
Common examiner traps. 1. Giving only the principal value and ignoring the 180-degree minus value. 2. Rounding your sine value before you take the inverse. Round only at the final answer. 3. Failing to label which sides correspond to which angles on your diagram. Write the diagram clearly and label sides A, B, C and opposite angles A, B, C. Write it even if the question includes a diagram.
Quick win. A checklist you can use immediately in every question. 1. Label the triangle with sides and opposite angles. 2. Choose sine or cosine rule, depending on whether the angle is included. 3. Write the full equation before you substitute. 4. When using sine rule, always list both possible angles and test them. 5. Substitute back or use triangle sum to confirm. Say it once before the exam and stick to it.
Memory trick for the ambiguous case. Solve, then check, then reject. Solve using the sine rule, then check by adding to the known angle or substituting into cosine rule. Then reject any option that breaks the triangle rules. Repeat it quietly when you look at an SSA question. It slows you down in the right way.
That's your quick win for today. Always list both sine solutions and verify them against the triangle. If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk. Stay curious.
Worked example. Timed exam style. Question. In triangle ABC, A equals 8 centimeters, B equals 13 centimeters, and angle A equals 30 degrees. Find angle B and side C. Step 1. Label diagram and write sine rule. Sine B equals B sine A divided by A equals 13 times sine 30 degrees divided by 8. Calculate sine 30 degrees equals 0.5, so sine B equals 13 times 0.5 divided by 8 equals 6.5 divided by 8 equals 0.8125. Step 2. Principal value B equals sin inverse of 0.8125 equals 54.0 degrees. Second possibility is 180 degrees minus 54.0 degrees equals 126.0 degrees. Now test both. A plus B equals 30 degrees plus 54 degrees equals 84 degrees, which is less than 180 degrees, so 54 degrees is valid. The other candidate gives 30 degrees plus 126 degrees equals 156 degrees, also less than 180 degrees, so both could be valid so far. That means two possible triangles exist. We must continue to find the corresponding side C in each case, or use context to see if the question expects both solutions.
Step 3. Find side C using the sine rule with each B. For B equals 54 degrees, C over sin C equals A over sin A. First find C equals 180 degrees minus A minus B equals 180 minus 30 minus 54 equals 96 degrees. Then C equals sin 96 degrees times A over sin A equals sin 96 degrees times 8 over sin 30 degrees. With sin 96 degrees approximately 0.9945 and sin 30 degrees equals 0.5, see approximately 0.9945 times 8 over 0.5, approximately 15.9 centimeters. For the other triangle, B equals 126 degrees, C equals 180 minus 30 minus 126 equals 24 degrees. C equals sin 24 degrees times 8 over 0.5, approximately 0.4067 times 8 over 0.5, approximately 6.51 centimeters.
Mark annotation for exam practice. Write M1 sine rule A over sine A equals B over sine B and show the substitution and calculation. M1
List B equals 54 degrees or 126 degrees, ambiguous case, and test with triangle sum. A1. Give final answers with correct units and rounding. For example, B equals 54.0 degrees, C approximately 15.9 centimeters, B equals 126.0 degrees, C approximately 6.51 centimeters, if the question asks for all possible solutions. If the exam only wants the acute solution, show your working and then state why the obtuse option is not asked for.
Sign off and resources. For a downloadable worksheet with this worked example and 10 more, plus step-by-step annotated answers, check the show notes. Subscribe for weekly episodes and spread the word to a revision buddy. Next episode, I'll cover circle theorems that crop up in foundation and higher papers, quick tricks that win marks. Trust the process and nail that exam. Stay curious.